Okay, chapter 3 begin to angle pairs and angle relationships and transversals. So this chapter is a lot about parallel lines and different types of angle pairs and what we know about them. So how can I identify the special pairs of angles formed by a transversal? So parallel lines, just to review, are two lines are parallel if they never intersect and they are coplanar. So in a picture, what they would look like, do my best. So those lines are not parallel. How we know they're parallel is if they are marked like this. If they have like arrows like that, kind of like the congruent hash marks, it's kind of the same thing. So these arrows mean parallel. Okay. A transversal, and I know you can see the color on this video, but if you printed the notes or in your note packet, you can't tell the color. But the transversal is that pinkish purple line. So it's the line that intersects two or more coplanar lines. So in this case, it will be line W. Like I said, that pinkish purple line. Then we can see that the two coplanar lines, if I highlight them, 1, 2, there are angles inside. Inside as in between, somewhere in here, right? That's inside. So the interior angles on the inside are angle 3, angle 4, angle 5, and angle 6. Those are all the angles on the inside. And then the outside will be out here. So outside those two red lines will be like angle 1, angle 2, angle 7, and angle 8. Those are all the exterior angles on the outside. Okay? So as you scroll down, alternate interior angles are angles on the inside that are on alternate sides of the transversal. And we abbreviate these as, you can call them AI angles. It's left to right. So these angles are on the inside. I know it's a small blank here. The inside of the two coplanar lines and on opposite sides of the transversal. So if you look at the picture above, like angle 3 is on the inside, and then on the opposite side of the pink line and the opposite side of the inside would be like 6. Those will be alternate interior angles. So angle 3 and angle 6. Another pair would be angle 4 and angle 5. I'm going to clean this up a little bit just so that it's easier to see when we go forward. Okay. Same side interior angles are angles that are on the same side of the transversal and are inside. We can abbreviate these as SSI angles, same side interior angles. And these angles are inside the two coplanar lines and on the same side of the transversal. So inside, same side, angle 3 and angle 5. Another pair of inside, same side will be angle 4 and angle 6. So 3 and 5, 4 and 6 would be inside, same side, so same side interior. And the corresponding angles we abbreviate as CORR. And these are angles in the same position. So if we look above, if you look at these two red lines, there's angles above and below and angles to the left and the right. So like above and to the left would be angle 1 and angle 5. Those are corresponding because they're both above a line and then to the left of the transversal. So angle 1 and angle 5. Another pair would be above and to the right. So angle 2 and angle 6. And then below and to the right would be angle 4 and angle 8. Those are corresponding. And lastly, below and left will be angle 3 and angle 7. So those are all the pairs of corresponding angles. Okay. Other lines we talk about, similar to parallel lines or skew lines, these are lines that do not intersect but are not parallel. So they're similar to parallel in that they don't cross, but they're not quite the same. So in the picture to the left here, you can kind of see the color there, but I'll highlight them just so you can really see it. Line PS and line RY, those are what we call skew lines. Because you can tell they're not parallel. PS kind of goes up and down, and RY is kind of like a horizontal line on the floor, kind of. They're never going to cross. They'll never cross each other, but they're also not parallel. So that's what skew is. Okay? So in our example, it says, think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? So it says, which line is parallel to AF and contains point E? So here's AF. It's parallel to AF and contains point E. So that would be EJ. So parallel to AF and contains E would be line EJ. Let me erase. This would be line EJ. Okay, part B. Which line is skew to AF? So here's AF. Skew to AF containing point E. So skew means it doesn't cross but not parallel. That would be ED. Because it clearly will never cross it the way those lines are going, but they're also not parallel. Okay, which line is perpendicular to AF that contains point E? So again, here's AF. Perpendicular to AF containing point E would be, change colors, would be this red line. Perpendicular because it forms a right angle. And we're going to assume those would be right angles here. AE is the only one that could be perpendicular through point E. So line AE. And then lastly, which plane or planes is parallel to plane FGH? So FGH, let me erase. FGH is way back here. It's this back one. Which plane is parallel to that containing point E? So parallel means never cross. That'll be this opposite end. So that'll be plane AED. The green plane and the red plane are kind of like two walls in a room. Opposite walls, sorry. Two opposite walls in a room. They'll never cross. And so it means they're parallel to each other. So those planes are parallel because they never will cross each other. Right, and then we have some checkpoints. So I'm going to quick fill in the answers to the checkpoint. I'm not going to spend a ton of time on it. A line parallel to MN that goes through point J. That'll be line JL. A line skew to MN that goes through point J. That will be JK, because line JK will never cross, but it's not parallel. A line perpendicular to MN containing point J, that'll be right here, JN. And then a plane that contains J and appears to be parallel to MNO. So parallel to MNO would be contain J, would be this red one, JKL. Plane JKL. Okay, then we have a couple postulates. The parallel postulate says, if we're given point P not on line A, then only one line goes through it. So let me draw the picture. So put a point, actually draw your best parallel line. My best parallel line is right there. Okay, put M on there. And if they're parallel, I'm going to put these triangle dashes, like that. So it says if we're given point P not on line A, what we conclude is that only line PM is parallel to line A. Okay, and just so you're aware, this symbol right here means parallel to, or parallel. So only line PM is parallel to line A. So if only one line going through point P can be parallel, any other line through a point P is not going to be parallel. That's what this theorem is saying. The perpendicular postulate is similar. So if we have point P not on the line, there's only one line that can be perpendicular through that point. So in this picture, point P is not on line A. Only line PQ is perpendicular. Perpendicular is an upside down T. I think we mentioned earlier this year, but this upside down T means perpendicular. So only line PQ is perpendicular to line A through point P. There's only one line through point P that's perpendicular, and that's line PQ. Wait. Identify parallel and perpendicular lines. Name a pair of parallel lines. So we're looking for these triangles. So the parallel lines would be line AB and line CD. Name a pair of perpendicular lines. Perpendicular needs the box. So the box right there is for line AB and line AC. Right. Is AB perpendicular to BC? So is AB perpendicular to BC? Explain. And the answer is no, because only one line, through C can be perpendicular to AB. And that's line AC. You'd also say there's no right angle box, so then we can't assume that's perpendicular. So checkpoint 5. In example 2, can you use the perpendicular postulate to show that line AC is perpendicular to line CD? Explain. The answer is no, and I'm not going to worry about the explanation too much because I don't want to get too much into the details of these postulates. Just know that only one line can be perpendicular through a given point. Okay. Example 3, identify angle relationships. Identify all pairs of corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Consecutive interior angles, by the way, is also same side interior. So corresponding angles are the same position. So first of all, we have the transversal is this red line. So the angles that are in the same position would be like angle 1 and 3. They're both above and left. Okay, angle 2 and 4 are above to the right. Angle 5 and angle 7 are both below the transversal and to the left. And then angle 6 and angle 8. They're both below and to the right. So those are your pairs of corresponding angles. Now, alternate interior angles are angles on the inside of these two green lines and on the opposite sides of the transversal. So alternate interior angles would be like angle 6 and angle 3. And also angle 2 and angle 7. Alternate exterior will be on the outside and opposite sides of the transversal. So angle 1 is on the outside, and that will be paired up with angle 8 because angle 1 is on the left outside and above. Angle 8 is on the right outside and below. And we also have angle 5 and angle 4 because angle 5 is below and left on the outside. Angle 4 is on the outside, it's above and to the right. Those are alternate exterior. And then the consecutive interior angles, or what I would call same side interior angles. Inside the green lines are angle 2 and 3. And they're on the same side of the transversal. The other pair, 6 and 7. They're on the inside of the green lines and the same side of the transversal. And then we have 2 checkpoints. They just say to classify the pair of numbered angles as corresponding alternate interior, alternate exterior, or consecutive interior, which is also same side interior. So number 6, 3 and 4 are on the inside. These would be consecutive interior angles. And I would abbreviate that, just it saves you so much time. So consecutive interior angles. And number 7 would be alternate exterior angles. Because here, here are the 2 lines. Angle 1 and 2 are on the outside of those lines. And you can see angle 1 is on the left outside. Angle 2 is on the right outside. So those are alternate exterior angles. Okay, and we're going to work on identifying these angle pairs and what we can find out from these angle pairs as we go forward in this chapter.